Hi guys, this is the second video we're going to use to cover the B5 topic, and it will look at making salts. This is a really important part of the topic because you have a required practical attached to this section. This means that in your exam they could ask you about how you would make the salt, observations you might see, correct chemicals or anything like that. So a salt, you've most likely only ever thought about table salt, but the name salt is given to any compound that is formed when the hydrogen in an acid is replaced by a metal. So when this happens, an ionic lattice is formed. Hopefully from your previous work in chemistry, you remember that an ionic lattice is made up of positive metal ions and negative non-metal ions. They're held together really tightly by their opposite attractions. So in the picture below, you can see how the lattice would look. For your syllabus, you'll be expected to know 4 ways in which a salt can be made. You'll have to remember the reactants and the products for these. So acid and alkali give you salt and water. Acid and metal gives you salt and hydrogen. Acid and an insoluble base gives you salt and water. So this is the important one because this is the one you need to do a required practical on. And the final one is acid plus carbonate gives you salt, water and carbon dioxide. Now we need to think about how we would make the salt. Although things may vary slightly, we're going to focus on the method that you would use for your required practical. We will carry out this practical when you return to school, so you'll get the chance to do it for yourself. I've included the keywords at the bottom that you'll need to be able to use within your descriptions. If you remember, the required practical looks at a reaction between an acid and an insoluble base. A base is something that can neutralise an acid, and the base that you're going to use is copper oxide. The acid you'll use is sulfuric acid, and so the salt you're going to make is copper sulfate. I'll explain shortly how you name a salt, so you will know how I got there. So firstly, you'll need to dissolve the copper oxide in acid. We use an excess, which is basically just saying using more than you need. This means all of the hydrogen is going to be removed from the acid and it will be neutral. Because we use too much, there'll be bits of solid copper oxide still in our solution. To get rid of these, we move on to the next step of filtering. This will separate the solid, which we can now call a residue, and the filtrate will be the clear liquid that comes out of the bottom. At this stage, we have a solution of just salt and water, so we can gently evaporate off the water and leave ourselves with just salt. You may hear this stage referred to as crystallization because you're making salt crystals. The next thing you need to know is the name of the salt you form. So the first part of the name is the metal within the compound that reacts with the acid, and the second part of the name is the acid itself. So if we use the example of hydrochloric acid and calcium carbonate, the salt that would form is called calcium chloride. So the first part, calcium, is named after the metal in the carbonate. The chloride part is there because you need to use, or rather you used hydrochloric acid. It's kind of like when people change their surname after they get married. So acids change the end part of their name after they react. So the 3 that you need to know are hydrochloric acid, which becomes a chloride, sulfuric acid, which becomes a sulfate salt, and nitric acid, which becomes a nitrate salt. The final part is quite tricky and relies on your knowledge of forming ionic compounds. So you'll need to know what the formula of your salt is. Hopefully you remember that a formula uses element symbols and numbers to tell you how many of each element is present in the compound. The example below shows carbon dioxide, and from the formula you should be able to see that it's got 2 oxygens and 1 carbon. So to work out the salt's formula, you need to know the charge of the metal ion and the charge of the non-metal ion. Because we know that salts have no charge at all, we need to balance the amount of negative charge and the amount of positive charge. To fully understand this, you need to know that all atoms are neutral in charge because they have equal positive and equal negative charge. Take carbon as an example. You can see that the nucleus in the middle is full of protons and neutrons. Our 6 protons give us a plus charge of 6. The neutrons don't have a charge, so they're pretty irrelevant at this point. But around the outside you can see that it also has 6 electrons. This gives us a negative charge of 6, therefore balancing the carbon atom out to be neutral. If you want to know the charge of an ion, you'll need to know if the atom will gain or lose electrons when it becomes an ion. All atoms want to gain a full outer shell, apart from hydrogen and helium, but we won't talk about that at this point. All atoms are going to want 8 electrons to make a full outer shell. Metals will always lose electrons and become slightly positive. This is because they'll only have 1 or 2 electrons in their outer shell. So it's easier to get rid of the electrons than to give them a full outer shell, than to try and take on 6 or 7 electrons to get a full outer shell. You need to remember the rule that the number of the group is equal to the number of the electrons in the outer shell. So you can see from my diagram that I'm using here, group 1 has 1 electron in its outer shell, group 2 has 2 electrons in its outer shell, then we go over to the non-metal side. Group 6 has 6 electrons in its outer shell, while group 7 has 7 electrons, so etc, etc. So that's true for everything that you look at in your GCSE syllabus. We're going to use the example of sodium chloride. The metal sodium, you can probably see, is in group 1. Therefore, it has 1 electron in its outer shell. It's reacting with chlorine, and that's in group 7. This means it's going to have 7 electrons in its outer shell, and it's going to want to gain 1 to give it this full, stable outer shell that we've been talking about. This means that sodium's charge is going to become imbalanced because sodium is going to donate its electron, giving it fewer electrons and making it slightly positive. Because the chlorine has accepted the electron from sodium, it has more negative charge than the positive, and it's going to make it a negative ion. So here, to give both atoms a full outer shell, only 1 electron needed to be exchanged. So this is giving it a 1-to-1 ratio, meaning that only 1 sodium and 1 chlorine came together to make sodium chloride. This means that its formula is just going to be NaCl. We haven't had to use any small numbers because it's just 1 of each. But this is not the case for everything. So look here at calcium fluoride. Calcium needs to get rid of 2 electrons, but each fluorine can only take on 1 electron. So our solution is to use 2 fluorines to each calcium. So this is a 1-to-2 ratio. So this makes the formula CaF2. So Ca is just saying we've got 1 calcium, and the F2 is saying we've got 2 fluorines. These examples also show the formula for molecules that don't have a 1-to-1 ratio of atoms, apart from the hydrogen chloride you can see up in the corner here. So just have a little look at the differing formula here. And finally, here is a table that lists out all the ions that you should know. If you're not good at memorising things, you just need to remember how to work it out, so it should be fairly straightforward for you. Okay guys, I hope that was helpful. Now you need to go on to Caboodle and do the task that I've set for you. If you've got any questions or you're struggling with anything you don't understand, please drop me a message on Show My Homework, or you can email me and I'll make sure I get back to you that day. Good luck.